Alright, so we're going to look at some other measurements we can do, or some other numbers that we can add to our way of measuring our data. Specifically, we're going to look at variance. And for us, variance will be a way of talking about how data values vary to each other. So, for example, we have a distribution, and I'll do it in bins, like such. We can see that there's a mean, a median, and a mode that's here, and there's a good chunk of stuff here. Another distribution can have the exact same mean, median, and mode, but it can be much more narrow, and more stuff is around the mean, median, and mode. So even though these would have the same mean, median, and mode numbers, the width of where everything is at is narrower. And so that's really what we start talking about when we talk about variance. It is measuring how far things vary, or how far spread out they are. And so one of the first things we start to do, and we've already done this when we were doing the bin widths, is we needed to calculate the range of the data. And that tells us how far our data is spread out across all of its values. And so the range is a good way of starting to talk about the spread of data. And the range is defined as the maximum data entry minus the minimum data entry. And I did discuss this in the previous lecture, but because we needed it to calculate bin widths, but I'll put it here. In fact, I did range. Oops. Let me get my pen working here. I did range as x, and I gave it a subscript for max minus x min. And this is the largest data unit entry, and this is the smallest. And you'll see I'll use subscripts a lot. Now, Excel is really helpful for us because if we get some column, let's say column B, we have all of our data entries in here, x1, x2, x3, x4, and so on, and we go to the data option and we sort descending, it'll find the minimum value and it'll put it in here, and then it will give us the maximum value. In fact, there's also functions to find min and max. And so when we have really large data sets, we can go right to our technology to help find the min and max and calculate range. When we have short data sets, one of the key things for doing this or making this work is just putting your data in order. And so from the books example, they give two pieces of data that we're going to use kind of in common here, because we want to look at what these data can do. So I will put this back up here and we'll use this as our beginning point. And so we have starting salaries. Whoops. What did I do? I went to the wrong place here. Let me go forward, back. I think I hit a tab over here. Give me a second to find my image. Ah, there it is. There we go. This is where we belong. Sorry about that. That was me a little there. Yeah, we're in a better place. Alright, so we have two corporations and we have their starting salaries. And so we have starting salaries for A. And we'll write all of these out here. It is 41, 38, 39, 45, 47, 41, 44, 41 again, 37, and 42. And I'll just put these in a set notation here. And so if I want to find the min or max, I should put these in order. And so the smallest number I think is 37, then 38, 39, cross them out as I do them. And it looks like my 41s, and there's 3 of them. And then I want a 42, 44. Whoops, I keep getting this pen's going a little wonky on me here. Let me try my other one. There we go, that's better. 42, 44, 45, and 47. Let's see if that's right. 42, 44, 45, and 47. And so some things we might visually see here is 41 is definitely a mode. And then if we look at the median's around here somewhere too. And these are things we'll look at this data more. But we see clearly that the starting salaries for A has a range of x sub max minus x sub min, which is 47 minus 37, or a range of 10. And we'll do a similar thing. Starting salaries for Corporation B. I'll change colors for Corporation B. I think I'll make them an obnoxious blue color to go with my obnoxious pink color here. And we had 40, comma 23, comma 41, 50, 49, 32, 41, 29, 52, and 58. And the range for this data, and we'll find, we'll put them in order eventually, but we'll find that the range for this data is, let's see, so 23 is the smallest, and 58 is the largest. So 58 minus 23, or 35. And so we have a different range between the two. Now, both sets of data have a mean. So the mean of A is 41.5, and the mean for B is also 41.5. And they both have medians. The median of A is 41, and the median of B is 41. They also have a mode, as I pointed out for A of 41, and a mode for B of 41. And so these data sets are very, very similar, but if we were to graph them, we were to put them into a bar graph or a histogram, A would look like this. While B has this general look to it. Most of the stuff in A is clustered near the mean, while B is more spread out. We can see that from the range alone. The range covers a larger distance in the numbers. And so if I were to randomly, start with either company, I would have a better chance of being near the mean here, because most of the data is in a narrow narrow window. But if I were starting with company B, there's a chance I could make a lot more money. There's also a chance I could make a lot less money. And so even though the numbers for this data, the mean, median, and the mode, are the same, the spread of the data is different. And so we're going to move from range to talking about deviations. And again, I'll cycle through some videos. I'm going to pause this video here, and on the next video I will talk about deviations.